Hello, everyone. This is the follow-up video to the one in which we created an error line. And now we're going to use that error line that we created in the previous video to determine the slope error for the best fit line. So what I've done here is I've created a few, populated a few cells with the labels mbest, merr, and delta m, where mbest is the slope of the best fit line, which is the value of 4.5176, and that comes from the top equation here, as well as the error, or rather the slope of the error line, which is 4.1089, which comes from the bottom equation right here. Now, in order to calculate the error of the slope for the best fit line, we just want to take the difference between these two numbers. Specifically, we want the absolute value. So we'll just go equals ABS bracket minus one value from the other. So with that, then, we essentially have what we need to report the value of the slope. In this instance, we are plotting position versus time. As a result, what we're actually getting for the slope is a representation of the velocity. So the slope of a position versus time graph represents the velocity. And in this case, then, what we then would be writing in place of m plus or minus delta m is the value for the slope of the best fit line, 4.5176, and then plus or minus the error, which is 0.4087. However, we have to remember that when we are dealing with uncertainties, we only want to present the uncertainty with one significant figure. So that means the 0.4087 is then reduced to just 0.4. Similarly, we also need to make sure that the value of the slope is presented to the same number of decimal places as the error. And so in this case, then, the decimal place is in the tenths column. And so then the same thing has to be for the representation of the slope. So instead of being 4.5176, it's going to be just 4.5. And so now this value, 4.5 plus or minus 0.4, is the value that we would report for the velocity. So that would be the velocity value plus or minus the uncertainty in the velocity. So with that now being taken care of, there's a few more aspects to the chart that need to be addressed. In particular, we need to add a few more elements. One of them is a legend. And so if we then click on the chart and we then touch the plus sign here, we see a bunch of chart elements appear, one of which is legend. So if we just hover over legend, we see that by default, it likes to put the legend to the right-hand side. However, you have the option of putting it elsewhere to be potentially a bit more aesthetically pleasing, depending upon stylistically how you wish to structure the graph. So here, if I just slide over and tag the arrow, then I have the option then to put the legend at the bottom. Now, if you look at the entries for the legend, you'll notice how we have series 1 being reported. Well, we would like that series 1 to be a bit more informative in terms of what that's supposed to represent with respect to what we're seeing here on the graph. So really, the blue line is the linear line for the best fit line, and the orange line is the linear line for the error line. So really, that's what we want to replace series 1 and series 2 with. To do that, we just click on the graph, right-click, select Data, and here then, in this particular option, we have the opportunity then to change the title series 1 to a more appropriate title. And so now with this being selected here, series 1, we go to edit. And then in this place, we could, for example, put in best fit line and select OK. Similarly, we can do for series 2 the same thing. And in place of series 2, put in error line and click OK. Click OK one more time, and we've now see that the line representations here are updated with the proper labels. We also have these two sort of what look like phantom labels, best fit line and error line. Those are supposed to be associated with the markers, but remember that we removed the markers, so now these two labels don't really have much purpose. We can actually now select each one individually and delete them from the legend. Be careful to actually select the actual entry error line without the marker to delete it. This now leaves in its place just the two entries in the legend, which represent the actual lines that we see on the graph. What we can also now do is we can move each equation over top of each of these entries and maybe even move the legend a little bit down. Again, we have to then keep in mind that there's going to have to be some potential stylistic issues considered as we move all these various elements around to make it all look a little bit tidy. But now I can put each of these equations on top of their respective lines more clearly. So it's very clear that this equation here that I'm highlighting is supposed to be associated with this linear error line, the one in orange. And this equation over top of the blue line is now represented with the best fit line. What we can also then do is go a step further then and also replace these various symbols with the appropriate symbols that we would be using for position and time. So typically we're not going to use Y and X for position and time. If in this particular instance we're looking at, say, something moving horizontally in time, we would rather use X for the position value and T for the X value. We can do the same thing over here as well. We can go make this X and make this T. In addition, what we can also do is be a little bit more clear that this X is with respect to the best fit line. And so what we can also do is select the best, and then up here, home, go under this particular font option, and then make that a subscript. Boom. And then we can also do the same thing here to tie in this X with the error line by putting in error. Whoops, one fewer R's would be good. And then selecting the error part of that label, and then again, just doing the same thing and putting in the selecting the subscript option to then have that be X error. So there's a number of different things that you can do to further tidy up these equations, but I'm just kind of showing you how to get going on that. Another thing that we would need to do for this chart is to provide an appropriate title, not just position versus time, but perhaps something a little bit more in the context of how this particular set of data was collected. Furthermore, we also would like to have another chart element added, which is the labels for the various axes, which we can then do as well by selecting the plus sign on the side here. So again, always select the chart. Whoops, let me just undo this chart here to then select the plus sign, and then you see here axis titles become available to us, and so that you have one available to you to edit for the vertical as well as for the horizontal. So rather than taking the time to go through each of these various elements and making the adjustments as needed, I'm just going to now flip to the final product, which you see here now, in which this chart has a title that has graph 1 to identify that there's, in fact, this is the first of potentially a number of graphs. So this is graph 1 with a title that's quite appropriate in that it explains what the data represents. So this is motion of a truck traveling at constant speed. And so this kind of relates back to one of the previous labs we did involving a truck where we timed its motion across the floor. And then on the side here, we have what the actual vertical axis is. This is the position, and the symbol that we use for position is typically X, particularly if the object is moving in a horizontal plane, and the units for position are in meters. Similarly, for the horizontal, this is time, where the symbol is T, and notice how the T has been bolded and also italicized. Same thing over here for the X, it's also been italicized. And then the units for time is in seconds. And then finally here for the equations, we've gone a little bit further than what I did in the previous worksheet. And that is here you see how it's X for the best fit line as a function of T is equal to square bracket, the actual value of the slope plus the unit of the slope, which in this instance being velocity is meters per second times T in bold plus, and then in square brackets again, the y-intercept for the best fit line, which is 0.7241 meters. And we've done the same thing here for the equation for the error line. So now this then is what all the elements are for this particular chart. If you happen to have a chart with a few more sets of data, say for example 3 trials of data, then your legend would have to then also include those extra figures and equations as presented here in this chart. So then there'd be another line for the other data set and another error line also for the other trial or data set with the corresponding equations linking to that particular trial. So again, a little bit of stylistic inputs required, a little bit of clerical work to kind of make sure that the various elements are clearly identified within the chart. so that what the reader is seeing is clear and obvious in terms of what the information is that is being conveyed. So hopefully with that, then we've provided a little bit of clarity into what needs to be provided and how to achieve that in this particular set of Excel charts. And with that, then I wish you all the best in completing this particular lab report, and hopefully this was of benefit to you. Thank you very much for your time.